EDX Core Pure Vectors for finding perpendicular distances. The perpendicular distance from a point to a plane. If we are given a point defined by alpha, beta, gamma and a plane defined as n1x plus n2y plus n3z plus d equals 0 in Cartesian form, then this formula will find the shortest distance from the point to the plane, and that shortest distance must be the perpendicular distance. It's worth noting that the form of the plane given we've looked at in a previous session, and that is the form required to use this formula most efficiently. The derivation of this formula is beyond the scope of the syllabus, but it would involve finding the equation of the line through alpha, beta, gamma, which is perpendicular to the plane, and hence finding where that line meets the given plane. So in this example, we want to find the shortest distance from the point A, which is 133, to the plane R dotted with 2 minus 1 minus 2 equals 1. So there's a couple of things to note before we start. If we look at the plane, we have the normal vector is 2 minus 1 minus 2, and we can get the magnitude of n by finding the magnitude of this three-dimensional vector, and we get 3 for the magnitude. It would be advisable as well to turn this plane equation into a Cartesian equation. So if we use r is x, y, z and dot it with 2 minus 1 minus 2, we get 2x minus y minus 2z is 1. And to make it as easy as possible to use the formula, I would write it in the form 2x minus y minus 2z minus 1 equals 0. So now it's compatible with the formula and easiest to use. So the shortest distance, which is what we're looking for, that shortest perpendicular distance, we can now get by finding the modulus of. The modulus is there just to make sure we get a positive distance. The denominator is the magnitude of n, which you know is 3, and the numerator is substituting the coordinates of A, which are 1, 3, 3, as the coordinates for x, y, z. So we'll get 2 times 1 minus 3 minus 2 times 3, and don't forget the minus 1. And that gives us the modulus of minus 8/3, and therefore the shortest perpendicular distance from A to the plane would be 8/3 in this example. In this example, we're given the position vector of the point that we are considering, and the plane has been given in Cartesian form. So again, looking at this Cartesian form, it might be a good idea to just pick out that normal vector ready to use with the formula. So that's 1, 2, minus 1, the coefficients of x, y, z, and we can find its magnitude by doing the 1 squared and 2 squared and 1 squared, which gives us the magnitude is root 6. So this time when we look for the shortest distance from the given point to the given plane, got modulus. The denominator is the magnitude of n, which is root 6, and in the numerator we need to sub in 12, 5, 3 into the appropriate form of the plane, and the appropriate form of the plane would be 1x plus 2y minus z minus 5 equals 0. If you have it equating to 0, it will make it easier to use. So that's 1 lot of 12 plus 2 lots of 5 minus a 3 minus a 5, which is 14 over root 6, and if we rationalise that and simplify it, we get 7 root 6 over 3 as our shortest distance. In the next session we're going to be looking at the perpendicular distance between two parallel lines.